This one looks pretty cool as well. Scale of the universe. I've seen videos like this before, but it's been a while. This one looked pretty cool. Always interesting to see like how small we are relative to the universe. Like you look down and like you see like an insect or something, or you look into a microscope and see like, single-celled or like, small organisms. And then you think like how small they are, but like in reality they're not much smaller than we are compared to everything else. Which is pretty, it's worth reminding yourself about how small we are. I don't know why. Just puts things into perspective, I guess. But yeah, here we go. This one is called The Scale of the Universe. Power of 10, Planck length, 4 times as large. Anything interesting here? Pistol star, whatever that is. Okay, let's see. Short video.
Powers of 10 are pretty cool. They're actually pretty powerful if you know what I'm saying. But what is a power of 10? In math, a power of 10 is any integer power of the number 10. Basically 10 multiplied by itself a certain number of times. Any number of times. For example, 10 to the power of 1 is just 10. 10 squared is 100. 10 cubed is 1000. You get the idea. The powers of 10 help us compare the relative size of things. Here, n represents any number you want. It's called the order of magnitude. A positive order of magnitude will make x bigger, while a negative number will make x smaller. The effect of adding one extra zero to the beginning or end of any number may seem irrelevant. But what happens if we take these numbers to the extremes? What might these numbers represent?
Not that I'm a flat Earth believer whatsoever, but I heard something interesting recently. Was that when people, obviously there's many ways to prove the Earth is round, but one way I thought was like very solid proof is that like when astronauts are up in the, up in space, you could see the little curve, the curvature of the Earth. But I heard recently that's because of like a fisheye lens, and that like the astronauts actually don't go high enough up to see the curvature. I don't know how real that is. I don't even remember where I heard it from, or if it's even true, but I was kind of surprised by that. I mean, obviously there's, several ways to like prove the curvature of the Earth, but I thought that was interesting. Whether it's true or not, I don't know.
Zero to the beginning or end of any number may seem irrelevant.
But I mean, every other planet's circular. I mean, you have to be pretty dumb to believe the Earth is flat, I think.
But what happens if we take these numbers to the extremes? What might these numbers represent? Believe it or not, the powers of 10 actually put our universe into perspective quite nicely. Let's start with the really small powers of 10. At 10 to the negative 35 meters, we come to what is known as the Planck length. Planck length is the smallest measurable distance in the entire universe. Much like at the center of a black hole, at a scale this tiny, the laws of physics break down and cease to be valid. The amount of time it takes a photon of light to travel one Planck length is known as the Planck time, and is equal to 10 to the negative 43 seconds. Meaning that this is the shortest measurable time possible. Any time shorter than this physically has no meaning at all. This is why, at the moment, scientists can only say that the universe came into being after it was already 10 to the negative 43 seconds old. Getting larger at 10 to the negative 18 meters, we reach quarks. These are the subatomic particles that compose protons and neutrons. 10 to the negative 7 meters, we reach the smallest forms of life, single-celled organisms. At 1/10 of a meter, you'll find things that you can see, like eggs, birds, and toilet paper. At 1 meter, we have everyday life, humans, dogs. Blue whales come in at a solid 30 meters. Next, we come across the meaning of life, or 42, whatever you decide it is. At
That's from a
270
movie.
meters, we reach the length of the Titanic. Triple that, and we get the population of Vatican City, the smallest country in the world. It's kind of funny because Central Park in New York City is actually 4 kilometers long, and is 8 times larger than Vatican City, which is an entire country. Clocking in at 11,000 meters is Phobos, Mars' largest moon. Fun fact, one day it's going to crash into Mars, so if we're going to colonize it, we should probably find a way to deal with it. With an order of magnitude of 5, we have Hydra, one of Pluto's moons. Even though it's a moon, it's only 100.
I'm pretty interested to like hear actually more about like how, like, does Elon really have a strong plan for populating Mars? Like, I don't think I don't know. Like, I don't know anything about this, but I can't imagine just like nuking the planet is good enough to like make it like warm for a long period of time. I could see maybe building an atmosphere within like some kind of like globe, or like, I don't know. Like there's a reason it's not populated. I think it's further from the sun, right? Like, it's really cold. Like, I don't know. I would be very very interested to see if he actually pulls that off or not. I mean, I agree it's important to like become multiplanetary, but like, is Mars really the planet we want to go to? Wouldn't it be like a planet that's like similar distance from the sun as to like what we are now? Something like that. I mean, I don't know anything about it, but that's just my sense of the situation.
Kilometers across. The state of West Virginia in the United States is actually 4 times as large. There's also about 10 to the 5 hairs on the average human head. At 2,300 kilometers in diameter, we have everyone's favorite planet, Pluto. Oh, wait. Anyway, moving on, with an order of magnitude of 7, we have Earth. At 12,700 kilometers, at a diameter of 200,000 kilometers, we have
Those are light years away, though, and we don't travel fast enough. Yeah. I've heard a lot of people say, like, you can fold time. I don't know. I'll believe it when I see it. Or you can, like, fold space, I mean. Maybe not time, but, like, fold space. I guess it's just a theory, but we'll see.
Proxima Centauri, the closest star to our Sun. It's also home to Proxima b, an exoplanet with features much like Earth. If there were to be a manned mission to any other star system's planets, Proxima b would probably be the first choice. With an order of magnitude of 9, the Sun clocks in at about 1.4 million kilometers wide. It accounts for more than 99.8% of the mass in our solar system. At 10 powers of 10, we come across the orbits of Mercury, Venus, and Earth, ranging from 36 billion kilometers from the Sun all the way to 93 million kilometers. Although these orbits seem pretty big, they're dwarfed by one of the most luminous stars in the sky, the Pistol Star. At 470 million kilometers wide, it radiates as much energy in 20 seconds as our Sun does in one whole year. But the Pistol Star is nothing when compared to the largest star ever discovered, UY Scuti. It is over 2 billion kilometers wide, and if it were to replace our Sun, it would completely swallow the planets of Mercury, Venus, Earth, Mars, Jupiter, and Saturn. At 26 billion kilometers, we reach what is known as a
What is this called? UY something?
UY
UY Scuti. So this is the biggest documented star. How did that... So how do they find it? Through like a telescope? Seen? I don't know. Seen? Is this... No, you cannot see it with the, obviously from the not the naked eye. How to spot it with equipment. Find the constellation. A good pair of binoculars, that's all you need? Or a small telescope, really. Huh. Wonder if there's a... So it's just like this. That's what we're looking at. I mean, if this is a real photo, this thing is not that much bigger than, like, something right next to it. You would think it'd be, like, way larger. But maybe you can measure the distance that it's, like, from us, and then, like, maybe everything else is closer, and that's why it seems larger or something. Any other good pictures? Like, it doesn't look that much bigger than anything else in these apparent actual pictures. Okay, anyway. Yeah, it could be way further away than everything else in the frame, so it doesn't look as big. I'm sure they have some way of determining that.
Scuddy. It is over 2 billion kilometers wide, and if it were to replace our sun, it would completely swallow the planets of Mercury, Venus, Earth, Mars, Jupiter, and Saturn. At 26 billion kilometers, we reach a day. It is exactly how far light travels in 24 hours. This distance is currently farther than any human or space probe has ever traveled. At 10 to the 14 meters away from Earth, our solar system appears only as a small point of light in the sky, just like every other star that we see in the night sky.
Yeah,
10 to the 15 meters, we have the Cat's Eye Nebula, one of the most complex nebulae ever discovered. The entire nebula is nearly half a light year in diameter. At 2 light years away from Earth, we reach the Oort cloud, a region of space filled with water and methane ice. 2 light years away from Earth.
What is a nebula? Never heard that before. It's a giant cloud of dust and gas in space, where new stars form? Or the remnants of a dying star, which is a supernova. Okay. Interesting. Okay, so a nebula is a giant cloud of dust and gas. Okay.
The entire nebula is nearly half a light year in diameter. At 2 light years away from Earth, we reach the Oort cloud, a region of space filled with water and methane ice. At this far distance, the sun's gravity no longer has an effect on objects past this point. Other stars are stronger. At 10 to the 17 meters, we have a familiar sight: the Pillars of Creation. Each pillar is over 5 light years long, that's about 48 trillion kilometers each. Everyone has seen these before. However, they won't last forever. They're actually already gone. The Pillars of Creation are located at about 7,000 light years from Earth, but about 6,000 years ago, they were destroyed by a nearby supernova, meaning that in 1,000 years, they'll fade away from our view and disappear into the darkness of space. Skipping forward to 10 to the 21 meters away from Earth, we can finally see the Milky Way galaxy in its entirety. Every star in the night sky that you can see lies within our galaxy. However, at 10 to the 22 meters, we reach the distance to our nearest neighboring galaxy, Andromeda. You can actually see Andromeda in the night sky with a simple pair of binoculars or normal telescope. 10 to the 23 meters, we reach what is known as the Local Group. Its name pretty much tells you what it is. It's the local group of galaxies that are near the Milky Way. We're actually the second largest, just behind Andromeda. The Local Group is a part of the Virgo cluster, a group of galaxies just like the Local Group, except much larger.
I wonder how they define a galaxy, like... So a galaxy is like a group of stars. So if there's another galaxy, is there like a lot of darkness in between these group of stars, and then they call the next group of stars another galaxy? Is that what's going on? I mean, that's what I would imagine, but... Anyways.
The Virgo cluster contains about 1,500 galaxies and is over 15 million light years long. At 10 to the 24 meters away from Earth, we come across the anomaly known as the Great Attractor. See, objects with a lot of mass have a stronger gravitational pull. That's why planets have moons and you don't. They're a lot more massive than you are. However, the Great Attractor is a bit different. It's pulling clusters of galaxies towards it, but we can't observe or see what it is. It's an object with a mass tens of thousands of times larger than the Milky Way's, but we don't even know what it is. At 10 billion light years from Earth, we come across the largest known object in the universe, the Hercules Corona Borealis Great Wall. It's a bit of a mouthful, but rightfully so. Why? Because it physically...
I feel like I've heard this before. It's like where people think the edge of the universe is. I don't know if that's actually true, but I feel like that's what I've heard it to be.
Should not exist. It is 10 billion light years long, 7 billion light years wide, and nearly 1 billion light years deep. This means that light would take 10 billion years to cross the entire wall only once. To put it into perspective, the universe is only 13.8 billion years old. In the time that Earth has been a planet, about 4.5 billion years, the light that has left at one end of the Great Wall hasn't even made it halfway to the other side yet. The structure is so big, it breaks laws of physics. There's something in the world of science known as the cosmological principle. To put it simply, it says, no matter where you are in the universe, if you look in any direction, you should see an even distribution of matter. This, in turn, creates a limit for the sizes of objects. It's about 1.2 billion light years, meaning that this structure is 8 times the supposed limit of the largest object possible. And at 10 to the 27 meters away from Earth, we reach the outer limits of the observable universe. This is as far as we can go and most likely will ever be able to. And thus, our journey ends. Just 27 steps ago, we were back at Earth, back at life as we know it. But the most amazing thing to me is that we traveled to the outer limits of our universe as we know it, reaching the largest structures known in the entire universe, and it only took us 27 steps. 27 orders of magnitude. But in order to travel to the tiniest limits known to man, at the Planck length, we have to take 35 steps backwards from the human level. This means that we are 8 orders of magnitude, or about 100 million times larger compared to the smallest thing there is, than the universe is compared to us.
It's a pretty interesting perspective.
And that, I find, is the most interesting thing of them all.
Huh. So there's more things that are smaller than us compared to bigger than us. At least in terms of magnitude. That sounds surprising, huh? I don't think I would have like guessed that or expected that. But maybe that's just how like proportions and exponential math works, if I'm even saying that right.
This video was made possible by Brilliant.org. Whether you're a novice or a PhD student, Brilliant has tons of online courses that can help even the smartest of people learn new and challenging ideas. Brilliant lets you learn at your own speed, so you don't have to work at a snail's pace. The best thing is they get right to the point, so you don't waste any of your time. You can learn about some of the most challenging topics and ideas and end up with a solid understanding in as little as 30 minutes. If you'd like to learn more about the world of math and science and support the channel at the same time, head over to brilliant.org/aperture and start learning today. The first 200 people to go to that link will earn 20% off of a premium subscription.
Alright, very interesting. Definitely learned a few things. It wasn't the video I was expecting. I thought it was gonna like show everything like comparative to each other. But it was kind of just representing everything in an exponential like exponential growth, like number wise. But I've seen videos where like they put, you know, the Earth next to another big planet, which is, you know, compared to the sun, which is compared to the largest sun out there, which was this last one, right? Uy Scuti. And then they compare that to, like, you know, they just keep going larger and larger. That's what I thought the video was gonna be. Very cool though. Very surprised that we are above average in terms of exponential size. Did not expect that.